we're going to dive into databases. Really, this is the final component that we've been looking for. Later on in this week, we're going to bring it all together with Node.js and Express by introducing a templating language. But databases are where we store and house all of our data, right? It lets us do things, pull data based on what user ID you have, slice and dice, merge, combine, sort, all the good things that you need to do with your data. Databases let us do. And we're specifically going to focus on one database, MySQL, and the SQL language that we use to interact with databases. Now, there are a lot of databases that use SQL, Oracle, Postgres, MySQL, SQL Server. They all use some form or flavor of this language. SQL stands for Structured Query Language. It's just a syntax that lets us ask for data, change data based on some parameters and some logic, which at this stage, you should be pretty comfortable dealing with logical kind of connections and things. So as I said, SQL stands for Structured Query Language, but most people call it SQL. You'll sometimes hear it referred to as SQL. Unfortunately, SQL is a trademark of IBM, right? So generally, software engineers who know better call it just SQL. You pronounce the letters instead of calling it SQL. Some people call it SQL still. I mean, both are right, but there is a trademark. So SQL refers specifically to a proprietary language covered that is owned by a company. So what is a database? Why do we need one, right? So up until now, you've seen that we've been doing all these things with local storage where we're storing data locally on the client side. We've played with some files a little bit. But in general, when we build web applications or when we build any kind of application, using a database gives us two major benefits. The first benefit is that it's persistent, right? We can store the data in the database and know that the information will be there for us to use later. The second major benefit, and this is why we choose SQL-based databases primarily, is that it gives us a bunch of built-in functionality to let us slice and dice that information. So if we've got 1 million records and we wanted to just get 10 of them, right? SQL gives us a mechanism to do that. If we want to get all the records for your roasting app where you gave it a 5-star review, SQL gives us the ability to do that. We can say, select all the records where the rating is 5 stars. Okay? It lets us play with and manipulate our data. There's a whole bunch of power functionality in here that we'll touch on as we go, but just know that we're going to scratch the surface and do the bare minimum that we need to do to use a database. There's a whole bunch of stuff behind the scenes for those of you who've gone to college or some of these classes where you can have automation happening. So every time you insert a record, it automatically inserts another record in a different place. Those are called triggers. We can also create views which combine data from a bunch of different sources so that you can query it easier. All of that stuff is really powerful and useful, but I've found that in my 20 years of writing software, all you really need to be able to do to use databases effectively is read data, update data, create data, and delete data, right? Like the common, it's referred to as CRUD. Create, read, update, delete. So keep CRUD in your mind. All the power user functionality, I've worked in teams before where we've needed, sharding and sharding refers to using multiple databases to contain one big data set. But until you go and work at a company that is operating on that kind of scale, when you finally get to a team like that, you'll generally have people whose entire job is to be a database administrator and to work as a database engineer. So they'll be mostly focused on handling the high-level crazy stuff, and you as a software engineer are still really just doing the basics, creating records, reading from the database, updating, and deleting. MySQL and SQL in general refers to a subset of databases that are relational, right? So we're talking about the relationship from one set of data to the other. Now, you can use a database, and very often you will, in which the relationships between various data sets is enforced entirely by your programs, right? You've got a users table. You might also have a user interest table, and we'll take a look at some of these examples later, where the relationship between the users and the users table is managed and handled by foreign keys, right? So a key or a value that exists in one table is also present in another table so that you can match them up. So user ID is a great example where you say I'm user ID 1. I've got another table somewhere else that is user blog posts. We saw this when we were looking at our fake API, right? Fake API. let's look at one of these, right? So comments, right? So all of these posts, all of these comments are related to the post that they're associated with. They all have a post ID of 1, but the comment has a special ID because each comment is individual. This is a relationship in terms of data, and so we're displaying that the relationship here is posts can have many comments. Okay. There are also non-relational databases. Those were very popular 5 to 10 years ago. Basically, when JSON started to get super popular, everyone said, let's just store JSON records everywhere. And so you saw a bunch of non-relational databases come up, like one of the most popular one is MongoDB. MongoDB just lets you store JSON objects and fetch them at a later date. It meets the criteria of being easy to, it meets the persistence criteria, and you can still query and get information out of it, create records, but it made it more challenging to like associate bits of data. The non-relational model is, it says you take a full data object of the entire relationship and you store it as one entry. Whereas in relational databases, they encourage you to break up your data across multiple tables. Cool. Any questions about like kind of an overview of SQL or databases in general? We're going to keep looking at it. No? All right. In general, when we talk about databases, we're talking generally about a server that is sitting somewhere handling data for us, right? The server is a SQL server. In this case, we're going to be using MySQL in this class, but it could be any piece of server software, like our web server example, where it's just a program that listens for an inbound connection, and if there's an authenticated connection, right, it connects, it lets you make some queries, and it returns data back to you. Inside of the server, we're going to have a number of databases. Okay, these databases can be unique. Generally, what I have found in my career is that you will create a separate database per project, right? So if I've got a server that's running, 10 different projects for me, I'm going to have 10 different databases. Okay. Inside of a database, you're going to have all of your tables. Now, tables are defined as the actual structure of how we're going to store our data. So you think of it as the server is the physical program that is running and listening to connections. The database is a collection of tables, and then a table is a collection of rows. Think of it like a spreadsheet, right? When you're building an Excel spreadsheet, the sheet itself is the primary thing, and then each individual tab, for those of you who have used spreadsheets with tabs before, each tab is a separate table of information. Okay. Tables are basically rows and columns. So an Excel is a really good example of this, right? Where it's like the columns define what information will go in there, and each row is a record that matches those columns. Individual values are sometimes referred to as fields or as cells. So just, that's some more lingo to be aware of. I often just call them values. All right. So when we're talking about SQL servers specifically are typed infrastructure, right? So just like kind of JavaScript had strings, arrays, objects, numbers, SQL has a few different data types. They actually have like 20 or 25. But the ones you'll use most often are these. Int holds integers, right? That's a positive or negative number. Generally from, negative 32 million up to positive 32 million. These can be, that's the default kind of like if you're going to pick a number and you don't need it to have decimal numbers, right? Like int is your friend. Tiny int is a single byte, right? So it can hold 1 to 255, right? So tiny int is a smaller version of an integer. Big int is a big integer, as you would expect. Oftentimes, when I'm building a program that I know I'm going to use on the internet for lots and thousands of people, I'm going to use big int as my column type, specifically because think of scale, right? If I've got users hitting this program every single day for a year, and maybe they're putting in comments or posts, this field can grow in massive size, right? And so we want to make sure that we have enough room in our column to store numbers up to 120. Let's look at the data sizes. I want to MySQL data types. Let's see. How big is big int? Here we go. Yeah, so big int, right, lets you store 2 to the 63rd power, right? Whereas int The most is, what is this? Hundreds, thousands, millions, 4 billion, right? So you can imagine if I'm building Reddit or something like that, right? They probably reached 4 billion posts 20 years ago, or 15 years ago, right? Within the first couple of years, just due to the nature of how quickly data from thousands and thousands of users are being added to the system. So BigInt is the perfect solution to this because it gives us such a big number that, by the time you get to the scale where you're running into BigInt being a problem, you should hopefully have a big enough engineering team to come up with a better solution, whether that's non-numeric integers or perhaps you used hash keys or something like that. UUID or something is pretty popular when this becomes an issue. Float, that's for our numbers that require decimal points. Float stands for floating point, right? So if it's 1, 2, 3, 4, 5, integer is the good choice. If it's 1.4, now you have to use a float. Varchar stands for variable characters, right? So it's some text string. Think of varchar as being like a string where you just need to store some number of characters between 0 and 255. Okay, so it's perfect for usernames. It's perfect for password fields. It's perfect for, a short summary or a bio. But it has a maximum limit that you cannot exceed. Text, if you want to be a blog post or you want to be able to store, the article of a story, text is the field you want to use for large strings, like entire documents, things like that. Think of the varchar as like the subject line of an email, and text as like the body of the email. Now, why do we even care about the sizes of these columns in the first place? What do you guys have any ideas? Why wouldn't I just pick text for everything and not pick varchar?
Will it dictate like the overall amount of memory or storage is available to the database?
Exactly right. So when we build our tables and we say this table is going to have an ID field for, let's say it's a users table. It's got an ID field, it's got a username field, it's got a password field, and it's got an email address field. If I made all those text, right, MySQL doesn't know how much data is going to be stored in there, so it has to allocate chunks on our drive and in memory to at least contain what could be put in, right? So if it's text field, right, if you got username as a text field, password as a text field, email address as a text field, right? That's potentially megabytes worth of information that is being stored in the database. Because the way that databases work efficiently is that it knows that it's storing the data in this format so it can find the next record by knowing what the maximum length of a row can be. So if you've got a varchar 12 and a varchar 30 and a varchar 45, right, it knows that the maximum number of letters until the next record will show up is like 65 letters. So MySQL can be super efficient by saying, row 1 starts at 0.0, row 2 starts at 0.67. Whatever the value of the maximum size of the previous row is, that's what will help it efficiently find the next record. When you start using some of these bigger sizes like text, right, MySQL will grow happily and accommodate whatever data you shove in there, but it can't be as efficient in knowing where the next spot is or knowing how much spot it needs to save for each of these things. So as soon as, like a text field, for example, as soon as you put in some text that is big, it makes the entire storage of the entire table take up at least that much space so that it knows that it can do that math operation to jump to the next spot. So text fields should be used sparingly when you need to store large amounts of text. Char is like varchar. I don't know why you would use char over varchar, to be honest. Let's see if it tells us anything in here. Maybe it just stores one letter. Go ahead.
Did you say you can only put like one data type per column, or is it like for the whole database?
Yeah, it's
So
one data type per column, right? So you're going to
okay,
say this column for username is a varchar field, and it stores a maximum of 15 letters, right? So that's a constraint that you're enforcing on your users, which says, hey, you could put in a username, but it has to be 15 characters or less. So generally, these days, storage is super cheap, right? We don't make those kind of ridiculous constraints like we used to do. So IRC is a famous program that used to be how we chat with each other way back in the 90s. IRC defined a nickname field as 8 characters long. So everybody would pick 8 character long usernames. That's how I got mine. These days, if you've got a username field, you make it 50 characters or 65 characters. So you're going to make it some kind of realistic constraint so that it fits most people's usernames, but it's not so big that you don't have to design your pages around it. Okay. Email address is another great example. For email addresses, most of the time I put in 180, 190 characters. There are valid email addresses that have more characters than that, but if that comes up, I might talk to my users and be like, do you have a different email address you can use? Because it's generally, you're going to find that 99% of your users are going to have an email address that's like 150 characters long at most. So why store the extra space?
And you would put those, you would check to make sure that on the client side, you do client side validation, or
Yeah, I would do a mix of both, right? So I'd put a max length on the input field so they can't type in more letters than that. Then I'm going to also check on the server side and be like, hey, you put in a username that is 181 characters long. That's too much. And I would return an error. But then the database is going to enforce it as well. If we make a table that is 15 characters long and you type in 16 characters, it's just going to silently truncate off the last one. So the whole reason I'm putting those constraints on the front end and putting them on the back end is because it can do unexpected things if you don't prevent them from doing it, right? So if I type in my email address is, me@ericharrison.info, for some reason, it chopped off the O in the database. When I try to log in, I type in me@ericharrison.info, right? It's going to search for that string, even though it's no longer stored in the database. Okay, and we'll look at that here in a bit. So, what does it say about char versus varchar? The length of the char column is fixed to the length you declare when you create the table. So anything from 0 to 55. Varchar are variable length. So this is what I was talking about, right? Like as soon as, right, if you do char is going to make every record in this table, it's going to allocate 4 bytes for the length of that record, right? Because we said char 4. With varchar, it's going to allocate whatever the biggest size is, right? So it's, right here, it's only allocating 1 byte. Then when you put in AB, it's allocating 3 bytes. Then you put in ABCD, well, now it's 5 bytes. So varchar is my go-to. I always pick this. But char, if you have very strict or very explicit data storage requirements, char is a little bit more efficient for you. But it's going to use that full storage requirement regardless of if there's any information in that cell or not. And then date. Date is kind of what you'd expect. MySQL has its own date format, so it's going to look similar to what we see in JavaScript. But the date field lets us run functions against it. So we can create a record and say, hey, put it, the default value to put in this column is the current date. Okay? We can also do some addition and subtraction. We can say, take the current date, subtract 7 days, and tell us what time was that, or add 7 days, right? So we can get a query range based on a week if we wanted to do that. The date column will let us store that and do date operations on it. There's also a date time field, which is just like the date field, except it includes a time component as well. And then there's a timestamp field, which is really intended more for like an event happening. So it's a date that you don't generally need to operate on. It's going to be the exact same kind of format as date time, but doesn't have that full range of date functions. So I'll use timestamp fields for things like a created on column or an updated on column when I just need to store the time at which something happened. We can also store binary information. Now this is highly context dependent. Just because, so binary information is things like photos, movies, pictures, Word documents. MySQL will let you store that information in here, but it is not recommended because you can't do anything with that data. Okay, MySQL can't search for content inside of a binary field, and binary data takes up tons and tons of storage space on the server. There's almost always a better tool for storing binary files than using MySQL. One good example is S3, right? Amazon has an S3 program that lets you store pictures, photos, Word documents, all of those sorts of things, and it's really easy to use. So if I had a program that had a user field, but the users could upload documents, I would put the record that the document was uploaded in MySQL, it was just a couple little text fields, and then I would put a link to the S3 place where I've actually stored the file. I'm going to let Amazon do all the heavy lifting with file storage and let the database just be how I reference those files in my applications. But in the past, I have had to use the binary file type. Sometimes you're working in an environment like the government where they say, we don't have an S3. We need you to upload a file, and you have no access to the file system. So all you can do is shove it into into your database. That's a thing. And then a relatively new data type, this is new to MySQL, Postgres has had this for a little bit longer, is the JSON file type, or data type. And JSON is exactly what you'd expect. You can upload JSON data so that you can send and retrieve information in a native format. The downside with JSON is that you lose a lot of the fidelity that you get being able to search other columns. Now, putting in a big JSON object in here might seem like a good idea because then your application can consume it. But from a database perspective, if you've got a whole bunch of fields inside that JSON object that you've stored, you cannot easily search on those, and you cannot easily join that information to other tables. So almost always, when you're talking about databases, specifically relational databases like MySQL, you want to have your data normalized, which means that you want to have each piece of information you care about stored in its own column inside a table that makes sense for it. And that if, posts is a good example here, right? Posts has a relationship to comments, right? Each one of these has a title, a body, and an ID, plus the user ID that made that post in the first place. We don't want to store the user information in the posts table. We want to store that in the users table. And we're going to reference who that user was by looking at the ID that was included in this post. This is basic data normalization. We're going to store each part of the data, right, with the correct table that it belongs in. So users, in this case, would go in a users table. Posts is its own table. Comments is another table, right? You can think of the relationship as this, right? There can be a user that can make posts, but a user doesn't have to make posts. This is optional, right? But a post will have been written by a user, so there's a relationship there. And each post can have comments, but that's not required, right? So that would be like the post to comments is what we would call a one-to-many relationship, right? One post can have many comments. One user can have many posts, can have many comments, right? Users is a one-to-many relationship to both posts and comments. Any questions about that? We'll dive more into relationships as we start building. Any questions about data types?
Does like the MySQL, the actual database, like the back end, can you actually look at the database and does it physically look like an Excel sheet or anything like that? Or
Kind of. Generally, here, I'll log into a production server here. So I'm going to pause the and how it's stored on the computer or on the server. So the data is stored in some kind of format, and how it's displayed out is, up to whoever made that program. Good question. All right. So there's a bunch of different ways that you can interact with servers, and this is getting more and more complicated as every day goes on, because now there are hosted database servers like Amazon RDS. That's a remote hosted version of these database servers. But what we're going to focus on here is we're going to set up a local environment with a server running on our personal machines so that we can do local development and test our code out. But generally, doing development locally is the first step to this entire process. So we're going to write our code, test it, make sure it works, and at some point we'll deploy it to the cloud or to some server remotely. And that is probably going to have a slightly different version of the database server that you're running, right? So if you install MySQL locally, you might be running a version that's one or two versions behind, and then you're going to deploy it to some server that is running the actual operating system version of that server, and it may be more advanced or less advanced. So we always have to be careful of what functions and features we're using in our environments to make sure that they kind of match up. Ideally, you'd want to have the same version of server running on your local machine that runs on production, but oftentimes you do not get that kind of option. So what we're all going to do right now is take a pause, and we're going to install a local development environment that includes MySQL so that we can start playing around. And so for those of us on Windows, we're going to be installing XAMPP, X-A-M-P-P. And so to do that, you go to xampp.com, maybe. Let's search Google for XAMPP. That's not right. Google XAMPP. Yeah, here we go. And it's hosted by Apache. And we're going to download this for Windows. Okay? Download this for Windows. For those of you on Mac, XAMPP, even though it says that it runs on Mac, is not good. You're actually going to use MAMP, and that is M-A-M-P. It's giving me the Windows if you go to this page, mamp.info, you should get it. It's going to tell you to download it in Mac. Let me know if that works for you Mac folks. Go ahead, Eric.
What if I have WAMP? Do I need to download a different one
Nope.
for what we're doing?
As long as you've got one installed, you're good.
Okay.
Yep. Because we just need it for being able to like have a database to play with. Yeah, WAMP is a pretty good one too. Oh gosh, why does it take me there? So does everyone have XAMPP downloaded or MAMP downloaded? Selena's got it. Eric Starlings has got it. How about everybody else?
Mine's downloading.
Okay.
I'm good to go.
All right. We'll just give Josh a few extra seconds.
What's the difference between NAMP Pro and NAMP? Is that just like a paid service? Is the Pro?
Yeah, I mean that's how they make their money. Pro has some extra features and lets you run different software packages.
Okay.
If you needed it, you would know. Your company would usually pay for it.
Okay. I just asked because it downloaded both online.
Yeah, I think what happens when you install MAMP for the first time, it gives you like a free version of Pro for the 14 days or something. But it doesn't do anything useful.
All right, I downloaded it. I'm good.
So everybody, what I want you to do is install that program. It's going to ask you a bunch of like next, click through. For you Mac folks, it might have you drag it to your applications folder. Let's just get that program installed. And what you should end up with for the Windows folks is a control panel that looks like this. And for the Mac folks, you have a slightly different control panel, but it's even simpler. I think it just has start and stop buttons. So let's get it installed and running. Let me know when you're installed.
Yeah, it gave us a 14-day free trial.
Yep. I've used MAMP like for the past decade, and I don't think I've ever once needed any of the features that were included in the Pro version.
It's good to know.
Hey, while we're waiting, Eric, you were saying like if you deploy your app and use like a a cloud provider to host the database. Wouldn't it be able to just, since everything is virtualized, wouldn't it be able to, if you were just like, hey, I'm running this version of MySQL or MySQL, shouldn't they be able to match that since everything is like virtualized and in the cloud?
In theory, yes, but what generally you'll see when you're using this kind of development environment like this, if you're using one of these tools, right? It has some version of MySQL that it installed in here as like a part of this package, and they don't update this very often. But what you'll see happening is that on like actual servers that are hosting real content, like Amazon is super quick at updating databases to make sure that we're patching for security vulnerabilities, making sure exploits are taken care of. Like they keep that stuff pretty up to date. So you might find that this version compiled, on April 6th, right, is like an entire version behind what is on Amazon. And they're not going to release a new one because this is a local machine development environment. Nobody's hosting it for real things. And so they're going to wait, until next April to release an update. There's just no telling one way or the other. What some companies have started doing, there's a program called Docker. And what Docker lets you do is run little tiny virtual machines on your computer. And so what a lot of places have started investing in is setting up the entire development environment as a bunch of Docker images so that when you go work at a company, they say, run this Docker image, which is going to give you a database with all the schemas for the work already ready to go. It maybe gives you the file system and a server, an Apache server, so that it's all ready to go. They're going to like recreate the entire production server environment as Docker images. So they can give them to you to run on your machine, and they'll run those same images on the production server. So places like that will often keep those things quite in sync. But if you're just using one of these, like, give me a little fake server on my computer, I just need it to run, right?
Yeah.
Just trying to verify my code is correct.
Okay.
Is everybody
Hey,
installed?
Eric.
Yep.
I have mine up, but you have an X on the service, and I don't.
You might
Is
be
that
running
important?
this is saying is installed as a Windows service. I must have installed it differently than you did, or I have like UAC controls turned on. So this is not installed as a Windows service on my computer. It might be on yours.
Okay.
Yeah, these programs are also sometimes extremely annoying in that because they're running servers that weren't really intended to be running on a desktop computer, oftentimes they'll expect to have access to ports and things that they don't have access to because Windows has blocked it with firewall or something. And so oftentimes, whenever I have to install this kind of program, I spend like more hours than I care to trying to get it to work. And then once it's done, I try not to ever touch it again. And then until the next time I get a new computer, and then I'm like, oh, got to go back and figure it out again. So is everyone installed? Okay. So if you click, for those of you on MAMP, I think you have an Apache and a MySQL button. You should be able to click Start. For those of us on Windows, right, we click this Start button here, which turns into a Stop button. And as soon as it's running, it's letting us know what port those instances are running on. So for MySQL, it's going to tell you it's port 3306. That is the default port for MySQL. MySQL on almost every server you'll ever use is going to be running on port 3306, unless for some reason your security team has decided that's scary, we're going to change it to a different port, but I almost never see that. Then it's going to tell you it's running Apache on port 8080. Now Apache, if you recall, is one of our web servers, right? Web server that most of you will get some exposure to at some point in your life, right? But it's telling us that, hey, port 8080 is now being hosted by Apache. So when I go to localhost port 8080, okay, this is my local Apache instance serving this web page content to me. It's not an Express server that I writ myself. It's not our Visual Studio Code. It's Apache. And I am here at phpMyAdmin. If you guys go to localhost port 8080, or for those of you on Mac, if it picked a different port for you, if you go to localhost, you should end up with some kind of page that says like, welcome to XAMPP or welcome to MAMP. And it should give you a couple of links. I can't show this off because I actually do real development and I have my actual server this is the software that I write running on this instance. But for you, by default, it should give you a page that has information in it that you can click on and see some links. Can someone share their screen and we'll just walk you through it? Maybe Olivia or Josh or.
Yeah, I can.
Okay, perfect.
Let me just put it open.
Perfect. Yeah. So when you load it up, right, this is like the landing page for MAMP, and they've got some news and stuff. But for you, for the Mac folks, your tools are hidden under the Tools menu. So if you click Tools up there at the top, then you click PHPMyAdmin, that's going to take you to this interface that I was showing off a minute ago. So this is your actual database running on your computer. PHPMyAdmin is a web-based database client, right? So the folks wrote this in PHP. The programming language, and it is just like a full-featured database client, right? So over on the left, you have all of the databases that are defined on the system. So you have just the ones that are there by default: MySQL, Performance Schema, Information Schema, and Sys. But if you click that New button right above that, it's going to let you create a database, right? So we were talking about a database contains tables. So what you're going to do here is you're going to type in a database name in that database name field. You can be anything you want. Yep. And then click Create. So right there, that drop down is for collation. And collation is the type of data that you're going to put in here. Now, generally, this is saying UTF-8, right? Unicode, general CI. This is like the default safe option to pick. It lets you put in, emoji and all kinds of normal, Japanese letters and stuff. But if you ever needed to work on a product that you knew was going to support specific foreign languages, there are better encodings for that language, right? If you were building something for an Israeli client, right? They might want you to pick an encoding that was better suited for Hebrew. Okay? And then you click Create. This is going to create your database. Okay? And so now you'll see over on the left, there is a test database. And right now there's no tables in it, right? That's what that blue box up at the top is telling you. No tables found in database. But you can create your first table by putting a name in this table box. Yep, no spaces. It's all going to be one word. And then the number of columns.
You do that?
Yeah, that's fine.
Okay.
And then the number of columns, right? So this is saying I want to create a database with or a table with 4 columns, and it's going to ask you after you click Go what those columns are. But you can just that's fine.
Sorry.
It's fine. So what it's doing here is it's showing you like this is the easy way to create tables, right? There is a syntax that we're going to learn here later today to actually do this in SQL because that's all it's doing behind the scenes. But what it's asking you here is name is the name of your your column. So if you type at that top name box, ID, for example. Okay, then you will make it int. Yeah. No length or value because ID is just the int is just a full length field. Then we're going to say default. Yeah, click that. Leave it at none. The default lets us put in a default value if we wanted to. So that if somebody doesn't provide it when we're creating a record, it's going to create something in there as default. And we're going to use this in a bunch of places, but not for the ID field. And then collation, you can ignore that column as well. But then attributes for the ID field, right? Right? Perfect. You're probably going to want to make this unsigned. Unsigned means it cannot be a negative number, right? So when we're adding an ID, we want to just go from 0 to 1 to 2 to 3 to 4 to 5. We don't ever need negative numbers here. So making unsigned says that it can go larger than that number we were looking at before, 4 billion. So instead of 4 billion, it can go to 8 billion or whatever. Okay. And then we're going to say auto increment, the AI field there. You put a check mark in there. And it has already made this the primary key. You notice that index value popped up with primary. So whenever you say this is auto increment on a MySQL database, it says, I'm going to count this for you. So it's kind of like an array, right? When we were working with arrays in JavaScript, when we push something in, it increases our index by 1. Auto increment is doing that exact same thing in our database, and it has turned it into a primary key. So there can only ever be one user ID 1 in this test table that you created. Okay, perfect. Now, that's really all you need to put in here for an ID field. I generally recommend that you put an ID field on each and every table you create, exactly like this. You just call it ID, you make it auto increment and primary, so that you can reference specific records, right? With MySQL, with SQL in general, we don't need an ID column. Okay, we can always say, hey, delete all the rows where the first name is Josh. But if we wanted to delete all the rows with the first name, if we have 10 rows with the first name is Josh, and I want to delete the 5th one, right? Having an ID field in there is super important. For those other tables, or for those other columns, you can put whatever you want in there. Name, maybe that's a varchar 55. But this is the process to create tables. And I'm going to take away screen sharing now, and I will take over. Any questions about PHPMyAdmin? This is just one client. Okay, there are other clients. For those of you on Windows, right? And I think there's a Mac version of this as well, because this is officially created by the company that makes MySQL. Go ahead.
Hello.
Yes.
Hello.
Hold on a second. And so what? Where was that? MySQL query browser is what it's called. MySQL Workbench. And so if the MySQL Workbench product is an official product created by the MySQL company it's kind of like PHPMyAdmin, but it gives you a different look and feel, right? It's an actual program, and I have that installed here on my computer, so I'll pull it up and just show this off. This is another good program, but one thing to note about this program is that it's sometimes buggy and will sometimes crash on you. So just be aware that, you get what you pay for, and this is free. So if I was to go to here, for example, right, this is my local database. So I have a bunch of tables in here. I can create new databases. Test. Great. Apply. Selected name. Oh, I already have a test. I'll just play with that one. So you can see this is just a regular old full Windows program. And they do have a Mac version of this as well. But in here, I can create tables. I can look at my data. I can call this test table. Okay. And then the format for this program just has you, rather than knowing the number of columns you want to begin with, right? You just type in ID, primary key, auto increment, name, varchar, whatever. That's fine. Email, varchar. We'll make this 150. Okay. That's an I click apply here, and this is the actual SQL that is being run behind the scenes to create this table. So we're going to look at this create table syntax here in a little bit, but it's asking you to review this before you apply. Okay, incorrect table definition. That could be a wrong comment. Okay, so we got an error here. Oh, primary key. I clicked the wrong button. Perfect. So now I have a table called test table. And if we look at it, go ahead.
So this MySQL or SQL Workbench is different than what we were just looking at. How? It's just a
a different program to interface with the database. So PHPMyAdmin is a MySQL client, just like MySQL Workbench is a MySQL client. It is connecting to the database and letting us interact with it, right? So I'm here in test table. These are both connected to the exact same database, right? I'm in here. I click test. This test table that I just created in MySQL Workbench is showing up in PHPMyAdmin. It's just letting us run queries, right? So if I do select star from test table, there's no records in here. If I put some records in here, Eric Harrison, email me at ericharrison.info, and I click apply, right now this information is being inserted into this database. Okay, now if I run select star, you'll see that's the record that's in there. And if I do that in PHPMyAdmin and I run select star again here, right, you can see that same information is over here. The client is just how we're connecting to the database.
Okay. And how do you connect the client to the database then? Because didn't we create it on this one right here that you're currently at? How do you connect your client on the MySQL database?
So when you're on PHPMyAdmin, it's connecting automatically to our database because that's how it comes packaged in your either XAMPP or MAMP, right? So they've already got it configured so that the database has a username and password that PHPMyAdmin already knows. And so it's connecting and logging in. When I was in MySQL Workbench, we kind of skipped over this step, right? These are the connections I already predefined. And so I was able to come in here and click plus You put in the host name, the username, the password, and then when you save it, it puts it in here as a server you can connect to. And so all I did was I clicked on it. And it's actually making a network connection.
Okay, that makes sense.
When we start coding, right, we're going to have to know the username and password as well as the database name so that we can write our code to connect to that database, right? So the MySQL npm package that we were looking at the other day, right? MySQL 2. This database library is a database client, right? Just like MySQL Workbench or PHPMyAdmin, it's doing the exact same thing. It's making a connection to the database and then letting us run queries on it. Okay, so you'll notice that this connection function, create connection, requires a host name, requires a username, requires a database, and probably requires a password. Same as PHPMyAdmin and same as MySQL Workbench. Now, if you're setting up your own databases, right, you'll know what that username and password is because you'll have created that table, you'll have created that user account. But if you're working in a company environment, they might just say, you know, the database connection was already created by our server infrastructure. If you want to make a database query, you're going to use the DB object or something. Or you might have an environment variable where all those are stored. How you get that information is going to be generally given to you. If you're building something by yourself, then you'll be creating that username, password, where's the server located, what host name is it on, and for our purposes, because we're going to be doing a lot of local development, right? The username is root, and the password is going to be, I think, password by default, but we'd have to test, and it's probably somewhere, but. We'll definitely find that when we get into coding later this week, so that we can make sure that we can actually connect to our databases. But I think it might be root with no password for local development, which is super insecure. But or it might be root sometimes, or root admin, like your run-of-the-mill generic default username password. Okay. So we all have something installed that lets us connect to our database and play with it, whether it's PHPMyAdmin. If you want to use MySQL Workbench, that's a good tool too. MySQL Workbench has like a bunch of analytics and other kind of crazy stuff in here that is sometimes useful. But I very rarely use those things myself. So, cool. And then, as we were showing off a little bit ago, like most of the time when I'm on a server, I'm connecting to MySQL from the command line. Right? I'm inside of a terminal and I'm typing out the commands to see what comes back. Because I'm not going to install PHPMyAdmin on my web server that I have running on the internet, right? Because then that's a vulnerability that can be exploited by random malicious hackers, right? PHPMyAdmin is a well-known tool that has a lot of exploits against it over the past 15 years. And so you'll often see bots looking for people that have PHPMyAdmin installed so they can exploit, you know, some vulnerability that was there and have full access to your database. So you're going to get comfortable writing and using SQL in a wide variety of environments. I mostly use PHPMyAdmin or MySQL Workbench just to look at data on my computer to make sure it matches up, right? If I write some code and I'm not sure if it's working, I might come in here and check to see if my record has been updated. I might actually create my tables in here sometimes, just so that I can use the interface that it lets us use here, right? This interface, and just, you know, kind of design my tables as I go. But more often than not, I'm going to use the actual SQL syntax to build my tables from scratch. Any questions about anything we've gone over so far? Okay. It is 4:53. Let's take a break. Come back at 5:10 and keep doing database stuff. See you guys in a bit. All right, cool. So we've learned kind of a little bit about how to connect to a database, how to run some commands and stuff. But let's take a look at each of these commands independently, because that's really what is happening behind the scenes, right? Each of these programs, whether it's PHPMyAdmin or MySQL Workbench, is just running SQL to show us information that the database knows about itself, right? And so when we're in here, right, we've got this list of our tables over here on the left, our list of our databases, right? That could be that can actually be done with show databases, right? With a semicolon at the end, which will give us a full list of all the databases in the system. Okay, show databases is going to show you all of those in there, right? So right now we're connected. We're not using any one of these databases, but show databases will get us there. Now, if we wanted to connect to a specific database so that we could start running all of our queries from inside of it, we can use the use command, and that's use. Let's do test. And when I run this query, right now, I mean it's hard to see, but I'm inside this database now, inside of test. So all of my other commands now no longer need to have the database prefix, right? So if I was to type select star from test table, right? Because we said use test, it kind of made that highlighted over here in the PHPMyAdmin. We're saying all of the queries that I run from here on out until I type use something else are going to be in relation to the test database, the test schema. Okay? And so if I click go now, this is going to run select star and show us the records that are in this database. Now, we were playing with the new command here, right? New is going to let us create a database, but generally, when I'm writing my own programs, when I'm writing code for myself, I'm going to create that myself using SQL. So I'm going to say create table, and then the name of the table, right? So create table test2, right? That's the first part of this statement is create table and then the name. Then I'm going to put in curly brackets, not curly brackets, parentheses, right? And what goes inside the parentheses is all of our table information. So ID, int, not, null, auto increment, right? Those were all the things we were selecting from the previous little things, the check marks that says auto increment. Int is the type, right? And then I'm going to say username, varchar, 50, not null, default, empty string. And then I might say email, varchar 150, not null, default. Yeah. And then at the very end, we're going to say primary key ID, right? So that's going to let it know, hey, there is an auto increment field, and the index for this field is a primary key and is ID, right? So this is the create table syntax. Any number of table columns that you want to put in here, right? You just separate them with commas. So if we wanted to have a, profile picture, right? Varchar 255, maybe it's a link, not null, default, and we could put in like HTTPS placehold it, 50 by 50, something like that, right? So it's going to have a default URL that we can put as a profile picture. Okay, so when I click go, this is actually going to create this table. You'll see that test2 shows up over here now in the left, and if I click on it, if we look at the structure, all of those columns that I just created with that create table syntax were created here. So you can see them. If you needed to change something, if you needed to tweak how it was done, right, you could do that from this interface, right? If we wanted to say, hey, the profile picture actually needs a different image address, right? Maybe we want to make this 64 by 64, right? Now the default is something else. Okay, if we ever wanted to see the create table syntax for a table that exists already, we can do show create table and then test2. All SQL commands end with a semicolon. So whereas JavaScript is extra forgiving and says, hey, no big deal, they end with a semicolon when you're inside of a SQL environment. Otherwise, it's going to continue to try and right, if I put, let's show this off. Right? Yeah, when you click show create table test2, the output here, if we, how do you expand this? You can copy to clipboard. Let's pull up VS Code real quick. Or Notepad, will be just easy. Right. How do you, options? Full, there we go. So this is the full syntax of that create table that I created. And you'll notice that it put in a couple extra things after my parenthesis. It says engine inodb. which is the actual storage engine behind the scenes. It's using the char set Latin 1 instead of UTF-8, so that's probably a problem for us if we were trying to build a more robust modern website. But this is a good starting point, right? I can create a table in PHP-MyAdmin and then save this into our project so that we have the actual table schema information stored in version control. Okay, that is show create table and then the name of the table you want to show. But let's say, okay, test 2, right? This is our table we just made. Right, like what if that's the wrong name? What if that's the wrong name of our table? Right? We can do one of two things, right? If we drop the table, it's going to delete it. Drop means delete. Or we could change the structure. There's probably a thing in here. How do we change? Rename, maybe? No, that's the indexes. I don't actually know how to do this. Let's see. Maybe there's a... Well, I'm sure there's got to be a way somewhere. Let's look around. Operations, maybe? Yeah, there we go. Yeah. Yeah, here it is. Rename table. So if we wanted to change this to users, for example, right? Click go, and now the table is called users. Okay, and that was hidden under operations for some reason. But you could also drop the table and recreate it just as easily, but then you'd lose all the data if there was information stored inside that table. Okay, so we've got records. We've got a record. Oh, we don't have any records in here. Let's create some records. So using the interface, right, I can do this. I can say, hey, I don't need to put anything inside the ID field because that's auto-incrementing. The username, let's say it's ERH. The email address, let's say me@ericharrison.info. And yeah, that's a good profile picture, I guess. So I'm going to click go. What's cool about PHP-MyAdmin is that it's showing you the query that it's running behind the scenes. Right? So it's saying insert into users, and then it's got the names of the columns after the users, and then it says values, and then the actual values. So it's insert into all the columns that you want, values, all the values that you want. So that goes in the parentheses, right? This is the format. You can take out ID, for example, because that's auto-incrementing, and we could take out null. It's important to note that whatever columns you have in your columns place need to match how many values you have in your values place. Like if I put null here, for example, and I try to run this, it should give us an error. Column count doesn't match row count, doesn't match value count at row 1. So it's saying, you said you were going to insert into 3 columns, but you provided 4 values. That makes sense, everybody? We take it out. Right, now I've got a second record in there with ERH. Right, if I click on the table, it's saying it's selecting star from users. So it's going to, star is the asterisk. It means show me everything. Okay, so it's showing you I've got user ID 1 is ERH, user ID 2 is ERH. Okay, if I wanted to, right, instead of putting a star here, I can specify just the fields that I want to come back. I can say just username, comma, email. I don't care about the ID, right? So it should show ERH, me@ericharrison.info. It's letting me pick what columns to display back because I put that in my select. So in the select statement, select is how we retrieve data from the database. We say select, then the columns we want, from, then the table we want. Okay, let's put some more information in here so we can keep playing around. All right, I'm gonna use insert here. Insert into users, username, email, values. Selena something at whatever.com. Good. Run this. Boop. Cool. One row inserted. Then I'm going to make one for Josh. Cool. Put it in line. I'm going to make one for Olivia. Okay. And as I'm adding these records, right, even though I've only said I'm specifying the username and the email address, that's fine because ID is auto-incrementing. And we put a default value in for the profile image. So these are all getting this placeholder URL included. What else do we got? Let's say Eric. Okay. Go ahead, Josh.
So this is all on the back end. How do you create an account on the front end? Like if a user wanted to create an account, is this all this information wrapped in like a form tag that's getting passed to the back end, or how does that map to the back end?
Yeah, great question. So, yes, you're kind of on the right direction, right? On the front end, we're going to build a form. Well, it'll be like a create account form, and they're going to ask username, password, what does your profile picture look like? Anything that you normally would see associated, that the service, whatever the service you're trying to build cares about, whatever data you want to capture, you're going to have a form input for that. Then the user clicks submit or create account, whatever the button is called. That is sending a post request to the server. And in our case, we're going to be writing express routes to say, hey, when app.post is like the new user route, grab all those variables that the user just put in and shove them into the database. So it's going to run insert into users just like this with the values that came from that form.
So you're not, is it creating it into a JSON object at all, or so it's just
Nope.
Okay.
It's going to be just creating it into a MySQL object that will look like this, right? So we're going to write code that says connection.query insert into table where, name values question mark, and you pass in the values that the user provided.
Okay.
I don't know if they have any insert examples in here. No, they don't, but we'll play with this a little bit today so you get a chance to see it in action. All right, who else am I missing? Okay, well, we've got some users in here now. It's good enough. All right, so we got a couple ERHs. We got a Selena, Josh, Olivia. All right, so the default here, right, is select star from users. That gives me all values, right? If I run this, it gives me all the values of all the records in this table because we have no constraints here at all. So we're saying select star, which is everything, from users, and full stop. So it gives me all 7 rows. Now, we also saw that I can say just select username from users, right? I can specify which columns to display back. So now it's giving me all 7 rows, but just the username column. Okay. So let's put all of them back in there, but I'm going to use username, email, profile picture. Good. But what if I just wanted user ID 2, right? And this is where MySQL starts to get really cool, right? Is that after the from, there's a whole bunch of other things we can do here, right? And the first we're going to take a look at is where. And so where is the clause that tells MySQL where some condition matches. So I can say where ID equals 1. That's going to give me one record that matches that exact criteria. If I wanted to see user ID 2, where ID equals 2. Or I could say where username equals ERH. That's going to bring back both of those rows that we created, 1 and 2. Or I can say where ID is greater than 5 and ID is less than 10. And that's giving me a subset, 6 and 7. Okay? Any type of, so this is the same type of Boolean logic that we were learning in JavaScript, where it's like a condition matches all of these things, right? We have and here saying both ID is greater than 5 and ID is less than 10. We also have the ability to say or, right? So I can say where ID is greater than 5 and ID is less than 10, or username equals ERH. Okay, so now this is going to give me 6 and 7, which is Karif and Olivia, and 1 and 2, which is me. 1, 2, 6, 7. You'll often see very complicated where clauses where people are slicing and dicing their data to just give them the data they want. Where is a very powerful clause. Now you'll notice that by default, it's ordering by this ID column. It's going 1, 2, 3, 4, 5, 6, 7, 8, 9. We can also, after the where clause, order by ID, and we can make this descending. Right? The default is ascending. We could say, I want you to be descending. So now it's sorted 7, 6, 2, 1. Okay? But we can sort by any field or column that is in our table. Right? So I can say order by username. Right? Now it's going to be alphabetically ordered by username, which is, let's take out our where clause so we can see all of our users in here. Okay. Right? So ERH, now it goes to 6, which is Eric, and then it goes to 4, which is Josh, then 7, which is Karif, and then 5, Olivia, and then Selena brings up the rear with her name beginning with an S. We can also make the username sort descending. So now Selena's at the top, and ERH is all the way at the bottom. We can also order by multiple columns, right? So you'll notice that 1 and 2 here, right? Because it's going ERH, E, well, it defaults to sorting numerically by ID, but we can come in here and say order by username desk, ID desk. So now you'll see that it still preserves the username as the first thing it orders, but when it gets to a row that it would have ordered, ERH, for example, that's the same value, so they have the same weight, but now it's ordering by the second tier of username, right? You can kind of see that it's showing this is the second thing it's ordering from. Okay. We can also, right, you'll notice that we're saying ID, username, email, profile picture in our columns here. That's the default. That was the order we created these columns in the table. But I can have them come back in any kind of order I want. I could say, give me my email address first. Email address first, and then maybe I have my ID at the end. Okay. And so now the return coming back from our database is email, username, profile picture, ID. So the order of the columns is defined by our columns list in our initial select. Okay. We can also ask for the same column a bunch of times if we wanted to. Right? Now we've got ID in there 5 times. Now, ID is a great example because generally what we'll do with MySQL is maybe you want to have ID plus 10. I don't know. So now you can see we're doing math on the return of that data. Right? The ID field, right? ID is not a good example. We don't often do math on an ID field, but you can imagine if we had a purchase price field and it had like $100 for your order, right? Well, what if we need to multiply that by a 7% sales tax? What is our total price? Our total price is purchase price times 1.07. So this ID field that we have at the end is ID field plus 10. So 13, 15, 17, 14, 16, 12, 11. Does that make sense? We can change the data coming back to us. We have not affected the data. It's still stored as 3, 5, 7, 4, 6, 2, 1, but the output is plus 10. That's select. We're going to play with select quite a bit, especially when we start talking about relationships between different tables, because that's where things start to get super fun. But this is the default syntax of select. Select, columns, from, table, where, order. Keep that structure in your head, because you're going to write millions and millions of select statements over the next 30 years. This will become like breathing for you, I promise. Okay? All right, let's say we wanted to update, right? We've got 2 ERHs in here. Let me go back to the default, right? I got 2 ERHs, right? Oops, that's a mistake. This second one is supposed to be Meg, right? So the where, or the update syntax is a little bit weirder, right? So update, and then what update does is it goes table name first, so update users, and then we say set column name. So we're going to say username equals, and then new value, Meg. Okay. But what we have to include here is a where clause, where ID equals 2. This is why it's really important to have an ID field so that we can individually update and modify specific records. We can do it without an ID field, but this is way, 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 way easier. And it makes sure that you keep things in line. So the update format is update, the name of the table, set, and then any columns you want to change. Right? If I wanted to change 2 things in record number 2, I put a comma in here, and I put a second field. So I'll say profile picture equals HBS placehold it. I make her, she's a 24 by 24 inch, right? So we're saying set these new values where ID is 2. So it's only going to affect that record. And if we click go now, right, it's going to say 1 row was affected. And if we were to look at our table now, we'll see that record number 2 indeed says Meg as the username, and it has a different profile picture than the rest of them. Okay, we've just updated this record. If I wanted to delete a record, go ahead.
No, I was just going to ask, how do you undo? Just in case I changed 2 and I meant to change 3. Is there any way to undo that? Or do I have to?
The short answer is no.
Oh, God.
Yeah. Be perfect all the time. Double check your queries. The long answer is there are ways to do this with transactions and with rollbacks and with audit logs and stuff. That is so far out of the scope of this course that just know, be perfect. Okay? You're often not going to have a safety net in the real world, even though it's technically possible to like roll back some of these changes. Whatever data is in the database right now is the pristine, perfect copy. And if you update it, right, the database doesn't know what it used to be. It's just a place to store things. So double check and verify every change you're making. Go ahead, Josh.
So with that, is there like, I don't know, like a best practice or something where you do back up your databases, like, or something like a backup database that literally just logs the same information twice, or anything like that?
Yeah, database backups are a pretty frequent common occurrence, but you don't want to back up your database every time you make a change, because you can imagine if you place yourself in the world of like building software that people use, they're going to be making changes to this database hundreds, if not thousands, if not millions of times a day, and your database might be gigabytes large, with gigabytes of data of information there. You know, at my company, we do 2 backups. Right? We do one at midnight. We do another one at like noon, and that's good enough. You know, we're comfortable with like, okay, if something catastrophic happens, we're going to lose 12 hours as worst case scenario. If I'm at Facebook or someplace, maybe, you know, we have hot swapping backups always running, so that like there's no possibility of data loss, except if I'm a user and I'm in here actually using your roast log, for example, and I edit a field and I change the temperature to 450 instead of 150, okay, well, the data has now been changed. So unless you have some solution behind the scenes that's tracking every update with like an audit log or some thing that says, you know, every time something is changed, store the value of what has changed. The problem with that is that now the more your program is used, the bigger your audit log will grow. Your audit log will grow exponentially larger than your actual database. So there are real world storage problems here that you have to consider. And this is why it's this is like database administrators, database engineers, they spend literally all day doing exactly what you guys are talking about, which is how do I verify our database is going to always be running? How do I verify that we have the ability to recover from a failure? You know, how do we make sure that we don't spend more money with an update record or an audit log than we do on our database? All right, and we're talking like even something at the scale of like Instagram or Facebook, right? They probably spend millions of dollars a month just on data storage. Millions of dollars a month. So things happen quickly at large scale when we're talking about data. I had a previous company that isn't even a commercial, they are a commercial entity that does not have databases publicly accessible. They're just using them to like store and do data science on. They have $116,000 monthly budget for data storage. That's a lot of money. There is, and you can imagine if they wanted to check a audit record of everything that has ever changed, right? That might be $800,000 a month instead of $100,000, just to be able to store everything. This is one of those things where when I'm inside a database running actual SQL commands, I am extremely careful with what I'm typing, and I make sure that, if it's something really crazy, right, I might even get a second set of eyeballs on it before I'll execute it. And some of the best practices that I've used over the years, especially when I was more junior, was things like making sure that if you're going to do an update, that your update always fails until you're ready to execute it, right? So if I said update users, set username equals, let's change everything to Meg, right? If I'm going to change everything to Meg, this query works right now, right? Where ID equals 1 million, right? This query fails right now, right? Or it doesn't fail, it won't do anything, right? So if I put a semicolon here, I run this, right? 0 rows were affected. So I might, while I'm writing my query, just to make sure that I don't bump my keyboard accidentally and submit something that changes every user to Meg, I might come in here and say update users where ID equals, some crazy long number, right? And then go in and actually do my set username equals Meg, where I want to go and say, okay, this is the correct code now. The last thing I'm going to do is put in the username that I want, the actual record I want to change, the actual ID. So I'm going to make sure that it fails. And if I was to accidentally hit enter at this stage when I was just typing this, right? This is now, okay, so PHPMyAdmin's even nicer. It's saying, hey, you didn't put a where clause in here. Are you sure you want to do this? But if you're on the command line inside of a server, it's not going to do that. It's going to be like, okay, that query's good. So this has now changed every username to Meg. 6 rows are affected. If we look at our thing now, I have just overwritten all of the usernames that were in here before. This is one of the main reasons why, as a junior engineer or as an entry-level engineer, most of the time you're going to be working in your local development environment with fake data. You're going to have a database running on your computer. Like this docket database that I have up here is for my day job work. When I'm writing new features, when I'm building stuff, I'm using this database. I can't possibly break anything on the production server. And then when I make a code commit and I'm ready to publish something, right? Like the database on our production server has all the good data in it. And when we need to make changes to that structure, we got multiple engineers looking at it. We make sure we're doing the right thing. There is nothing worse in life than fixing a database you broke at 8 p.m. on a Friday because you thought you could get away with it. Any questions about update?
So you're saying, though, it's best practice to not use this PHP myadmin GUI and just use the command line because
Yes.
this has all these vulnerabilities in it.
Yep.
So you would never even. So you were saying that you might come back here and check your how everything's laid out in here.
Yeah, while I'm building software, right? If I'm writing, and Docker is a great example, right? Because that's my day job. So these are all the same tables we have on our production server, but all of the information in here, like
Okay,
all my
so it's
users
not
account is my stuff locally, right? I'm creating fake accounts, fake data. I can go in there and write new features and write code that still can query the database, just the local database, and like, am I verifying my code is working?
Got it.
Because we're never in here writing SQL to actually make our applications work. We're writing code that has SQL in it to store data for our users. We're writing code like this, right? We're saying, I need to get the information from this page and display it or something, right? We almost always live exclusively in our code editor. The tools are just here so that while I'm writing code locally, I can go and be like, I clicked the update button, but nothing is displaying. Is it actually stored in the database? Well, I don't know. I come in here and click and look.
Okay.
Good question. So we looked at we looked at select, looked at insert, we did update. Then, if you wanted to delete a record, the delete syntax is similar to the update syntax. If we look at users again, right? If I say, hey, I don't need 2 Erics in here, I don't know how I ended up with 2 Erics down at the bottom. So I'm going to say delete from users where ID equals 7. Okay, this is another super dangerous one. If I say delete from users with no where clause, that deletes from users. Okay, so this is another example where I might not even put in the table name until I was guaranteed that I have where ID equals 7. Then I'm gonna come back and be like, that's good stuff. Then put in the table name, delete from users where ID equals 7. Oh, there's even a simulate query button. I don't know what this does. This is pretty neat. Okay, so it's telling you if you ran this SQL query, delete from users where ID equals 7, it's going to match 1 row. Let's take where ID equals 7 out here. It's telling you it's going to delete 7 rows. So this simulate query button, I don't know what this is actually doing. This is like a PHP MyAdmin thing. They're probably changing that to a select to see how many were affected. But that's, you know, a good button to maybe try for some of these things that have no fallback in case you do it wrong. So now I've deleted user ID 7. So you'll see now that Eric is number 6. Let's insert another record here. I want to show this off, right? So we just deleted record 7. Insert into users, username, email, values, Eric Thompson. How do you spell your last name? Thompson. At gmail.com. Cool. And I misspelled insert. Insert. Cool. So this is going to add a record. You'll notice, if we look at our information here, it gave it record ID 8. It skipped over 7 because it was already assigned. The auto increment functionality behind the scenes in the database is tracking the next number that it can assign to. So if you deleted 15 rows, if you deleted everything in here, if we insert a new record, the next one would be 9. It would not go back to 1. It doesn't fill in gaps. If we tried to insert, right, because we made this a primary key, this is also treated as an index. If I was to, right, insert a record in here, insert into users, ID, username, email, values. If I put one that has already been assigned, ERH2, right? This is going to give us an error. It's going to say duplicate entry 1 for key primary. It's going to prevent us from doing this. Now it does not prevent us from, how do I close this thing? There we go. It does not prevent us, right? We skipped over 6. We skipped over 7 because we just deleted that. I can manually put a new 7 entry in here. Oops. I click go now. Now there's an ERH2 in the 7 spot. The constraint here is preventing us from having a duplicate entry because it knows a primary key is like the official formal address for where this row is stored. Okay, but if we delete one of them, delete one of these records, it's going to skip over it with auto increment and continuing to count, but we can always create, it kind of keeps that place open for us. Any questions about that? So select, update, insert, and delete. Those are the 4 things you'll do 99.999% of the time. We're going to talk about alters. Go ahead.
So once you make one of those statements, select, update, delete, or insert, in the MySQL database returns whatever you wanted, it automatically sends it back to your server. Is that how that works?
What was the question?
So we have like a query for this MySQL database. We want to get the username or whatever, the emails.
Mm-hmm.
We get that, and then it just sends it back to the server automatically, or how does that work?
So like in your example, you want to get the email. So we write a query that says select email from users where ID equals 1. I want to get ERHs.
We're writing this though, like that statement, you're going to write it in Node, correct?
Yep, correct.
And that's going to go to the database, the MySQL, and then it just automatically returns your response.
That's going to depend on what library you're using, right? So we're going to use MySQL 2 here, and so it's going to it works kind of like a bunch of other things, right? You're going to say connection query. You put in your query in here as the first parameter, and then you've got a callback function that actually does stuff with the results of that query. And so we'll say things like console.log result. Maybe that's what we do next, is we like play with this in Node, so you can start to maybe get a mental model of this. Other programming languages, or even sometimes other libraries that you might use for databases, are going to do things differently. So just like with everything else, you're going to have to read the library information to know how it's passing information back to you. So let's play with it here. VS Code. Let's pull open a new project. Okay. This is our little get body thing. Let's open a new one. New project. Open folder. Let's see. CBC13. New. We'll call this MySQL Intro. Okay. And just like with everything else, we're going to go through all the regular steps. So terminal. Close that nonsense. And I'm going to say npm init. Let's turn this into a Node package that we can use. All that's fine. Good. Yes. Okay. So now we're a package. I'm going to say npm install MySQL 2. So now I can actually connect to a database because that module is here for us. I'm going to create my index.js, and we'll just play around. And so what I would normally do is I'm going to come here and I'm going to say, okay, well, this looks correct. That's how we connect to the database. Here's how we make a query. I'm just going to copy these 5 chunks and just paste it right in here. Let's see. What did I name my database? Oh boy. We called it test, and the table is called users. Okay. So root test. Good. Select star from users. Let's just select star and see what happens. Okay. So we got the thing. So I'm going to run this with node index.js. So it did output something. Ooh, okay, cool. So results is the results. Fields looks like it's giving us a whole bunch of stuff in here, like column definitions. I don't know what any of that's for. Oh, okay. These are all the fields coming back, right? So it's got an ID field, a username field, and it's giving us like some binary information to let you know like where it starts. None of that really seems to be useful, but we're getting like usable data from our database now, right? In a way that we could use it. Right? And so if I close, right, if I close this project, right, and I run it again now, it should just output my username data, right? It's in the results array, right? Results here is an array that has a bunch of objects in here with key value pairs for information coming back, right? So if I did, let's see, let's write a loop, right? Because it's an array. So instead of console.logging, let's write an array, a loop here. So we'll say for let I equals 0, I is less than results.length, I plus plus. Right, so let row equal results I. Right, so I'm creating a variable to hold each individual record as we loop through the results that are being returned to us. So now I could say console.log row.id, row.username, row.email, right? All those fields, because this is an object. So these are key value pairs. Email has the value in it. And so if I run this now, it should, instead of just displaying JSON to us, it should, yeah, it's console.logging at 1, erh name. And so now we're at a place where like this is just a simple script, but we're able to connect to our database. We're able to make a query, right? So you can imagine if we were building an Express app where you go to a page called /users and it queries this database and gets a list of all the user accounts that exist. Then the user clicks on /user/5. Well, that should load Olivia and her information. And then we put all that in a form, and we can maybe make a little update feature so that when I change her email address to olivia@somethingbetter.com, and I click update, it's just updating that one record. All right, let's do that real quick. That should be super simple to build. Let's okay. So I'm going to npm install express. Good. I'm gonna make a. Let's see. What does this say? Operation not permitted. Rename node module QS package JSON. Oh boy. Oh, probably because I was running. I don't know. Let's see if this installs. Okay. Weird random bug that I've never seen before. Figures. Okay, cool. So let's install Express. Let's turn on Express. Const Express equals require Express. Const app equals Express. Okay, so we create our thing. Then we would say app dot use express dot static, and we'll say public. So we'll give ourselves a file where we can store some stuff. Oh. Okay. I'm gonna make a folder. What do we call this? Public. And in here we'll just make a style.css, right? Maybe because we want. I don't know. All right. Let's think about this. So we got our connection. I don't like this formatting. Okay, there we go. Good. All right. So we need to have a listen, right? App.listen, and we'll maybe make this be slash, right? So you go to this page, and app.listen is app.get slash, and when we go to this page, res, right? It's going to load a full list of users. Load a full list of users. Okay. Oh no. Messed it all up. Good. Alright. So when we go to this page, it's going to load a list of these users. And then what it's going to do is it's going to output this to our maybe what it does is it loads it as a JSON object or something and returns it for an XML HTTP request object, or maybe it just displays it on the page. So let's do that. Let's say let's create an output thing here. Let output equals UL. Okay. And then as we're going through this, right, instead of console logging this, we're going to just put it in this output. So output equals output plus li. Let's make this a template string so it'll be easier to work with. Li, and then we'll say row dot id row dot username. Right, great. And then slash li. And then the very last thing we'll do after we're done with that is we'll close out our let output equals output. Oh, can't let again. Output equals output plus close our owner list. Okay, and then inside this callback for where the database connection is finished, right? This is where we're going to say res.send output. Okay, well, let's make sure we create our connection above this app-get. Right, great. So we create our connection, and then we create our server, our Express server. Yeah, great. And when we get into templates later this week, right? Instead of just sending out an unordered list, we're actually going to send this data to a template that already exists that is already nicely structured, so that the template will render this beautiful unordered list. If I was to save this, I have to do app.listen, and we want to say, let me say like a 5, 5, 5, 5. Great. So now when I load this node index.js, right, I've got a server now running on port 5555. If I go to localhost 5555, that's a list of users from my database. Now, if I wanted to make these clickable, right, I would have to put something in here, right, like href equals user, and then maybe we put in row.id as a part of the href we're going to, right? And if I say /a, restart my server, reload this page, now these are all links. And if I click it, right, user 5, we haven't written that route yet. But what I would maybe do is come in here and say app.get user and then user ID, right? Because we want to put in a parameter, right? This number that comes in at the end is always going to change, right? And then we do function res. And what we're going to do here is we want to do the same query, but we want to actually use the information that's passed to us from this request. All right, so let's do that. So we know let user ID equals rec.params.user ID. Right? That's how we get this value out of here. It's in rec params. Then we're going to say connection.query. Let's just copy this whole thing. Okay. So instead of just select star from users, we're going to say select star from users where ID equals question mark. And what the question mark lets us do is it says, hey, rather than hard coding in this value that we're getting from up here, we're going to use this as a placeholder. Okay, so we're going to pass to you what the value is here, and we do that here in an array. We can say user ID. Right, it has to just be in an array, I think. Cool. And so now, right, there only should be one record in here because we're saying where ID equals, in this case, 5. So this should just return a single user. And if we restart our server, now let's reload. Yeah, we get Olivia 5. And if I change this to user 6, that's Eric. If I go just back to nothing, we get the full list. Now these are all clickable, and it's loading each of these records from the database. Pretty cool, huh? Now, this is a table that doesn't have very much information in it, right? It's just user list. But you can see that when we start bringing in other things we've learned in HTML, building nice pages, building forms, us being able to suck information out of a database and then store it again for later use means that we can have the content of our pages, have the content of our programs persist over time, and we can really start to build some interesting things, like your roast log thing, Josh, where you can, every time you make a roast, it creates a main roast table entry, and then it has all the steps for each roast associated by ID, so that a roast can have many steps or many minutes, and it can have a rating, and it can have, you know, a coffee brand or whatever, right? So all the things that you've been trying to do, databases allow us to do that for the first time because we can model and structure how to store and access that information. And then from a coding perspective, it's extremely easy for us to like fetch that information using SQL. Go ahead, Josh.
Can you like nest a table within a table? So like each user would have their own account with their own whatever information you're trying to store for each person. So like for me, each person logging in has their own roast log.
That's the beauty of relational databases, right? And we're going to take a break in a minute, but maybe we'll use a roast log as an example of like what makes this so powerful, right? So because let's say there's a user ID, right? I'm user ID 1. Okay. By simply including user ID as a column in any of your roast tables, then you can essentially grab any roasts that belong to me. And then if you're user ID 2, all of those belong to you. So you just include that user ID in the where clause of your queries, right? So that when I log in, everybody shares the same database. We're all in the same table, but my information has my user ID attached to it. Your information has your user ID attached to it. And maybe what you do is you have an extra column in your table that says public or private. Maybe it's private by default, but you have a public option. So I can come in here and be like, this roast was excellent. I want to make this available to everybody. And I click public. And so now maybe your query says where the user ID belongs to you, Josh, or it has been marked as public by somebody else.
Okay.
So we can all share the same resource. We don't have to make new tables for everybody. We can all share. Everything will get shoved into a table, but that table will be shared across everyone that uses the system. Cool. Good question. It is 6:01. Let's take another break. Come back at 6:15, and we'll maybe start taking a look at relationships.
Temperature?
Okay. The temperature of the overall roast.
Yes.
Okay.
Yeah.
Because I know that each minute had a temp as well, right?
So there's like what you start your roaster at. So yeah. So like the
target temperature.
Yes. Yeah.
Okay. And that's just going to be. Do you care about like precision? Is 105 degrees 0.5, like 105.5? Is that the level of precision you care about, or is it
just the whole number?
105, 106. All right, we'll make it an int. Default. What's the default? Like I don't know, 10 degrees or 0 degrees. Let's make it 0. What else?
Well, I guess I kind of went out of order. Like the roast date when you actually roast it.
We'll make this a timestamp, not null, default now. Not null, default current, timestamp. Okay.
The batch size. So like how many ounces, like 10 ounces of coffee are you roast, or how much a pound of coffee?
Okay, so it's got some value and then also some
measurement
unit, right?
Yeah.
So batch size. Let's just make this. I mean, this one can be a double, right? Or this could have precision, like 4.5 ounces, right?
Yes.
So we'll make this a float. Okay. And then we have batch size unit. Will be maybe a varchar, and we'll make this. We're gonna be like ounces, pounds, grams.
Ounces and pounds are like the two that you would use.
Okay.
The only two, really.
So this probably just needs like 10 characters. And what's the default? Do you think ounces?
Yes. Yeah.
Yeah, perfect. Okay. What else?
The name, like the coffee type.
Well, it's just like Folgers or something.
Yeah, kind of
It's
like what region it's from. So.
Okay, and then good. What else?
And then there's like the roast temperature by minute.
But that's minute by minute. That also have notes as well, right?
Oh yes, yeah. And then
so we're gonna store that in a separate table.
Okay. And so yeah, just the only thing we're missing is the notes and the temperature by minute.
Okay, good. So on this table, right? So we're talking about relationships here. So primary key ID, right? So a user can have a roast. Okay, so in order to associate this to a user in our system, we're going to also add the user ID. Int, not null. Not null. Cool. So by simply including a column to store an ID for a user, we'll be able to associate a specific roast to a specific person that exists in a different table, right? And so we've built this table now. We've got ID, which is the ID of the roast, user ID, which is a foreign key relationship to a different table, target temp, roast date, batch size, all of that is good, right? So I'm going to click wherever the go button is. Go. Oh no, what do we got here? Oh, we got some errors have been detected on the server. Ugh. Okay. So let's try this in the MySQL workbench. Let's see if we can make execute. Did it make it? Yeah. Let's see if we have an error in here. Okay, great. Let's refresh. Tables. Okay, great. So it worked. For whatever reason, PHP went kind of crazy when we. Oh, yeah. So anyway, this table exists now, right? So the perfect use of this is that like roasts is a table, and let's put a roast in here. Let's update it in here. That'll be easier. Okay, cool. select rows. All right, so I'm going to put in user ID is 1. That's me. Target temp. What's a good target temp? 190. You're muted again.
Sorry. It's like actually like 350.
350. Holy moly.
Yeah.
Okay. Roast date. We'll do today. That's great. Batch size, and I'm going to say 4 ounces. Ounces. Good. Coffee type, and I'll set Colombian or something. Cool. All right. So I have a record in here. Okay. Because we put in a column to associate a user ID from another table, we can introduce a concept called a join. Okay, and what a join is it joins information from one table to the other. Right? We know that select star from test roast is going to pull all the records from in here. Right? If I did select ID, user ID, target, temp, roast, date, batch size, batch size, unit, coffee type. Right? So this is the query we're running here. Okay, it's the same thing, but select star gives us everything. But I also have user ID. I want to get what's that person's username, maybe what's their email address, right? We want to get like first name, last name, that sort of stuff that normally would be in a username table. So we're taking this from test roast, but what we can do is we can say left join users on roast.userid equals users.id, right? And if we just run this right now, it's not going to do anything different. Join test users. Did I not use the users table? Where's the here, let's do this. Use test. What is it? Okay. And I'm gonna paste this in here. Let's beautify this a bit. Why does it keep scrolling over? That's annoying. Left join. Oh, probably because I've got roast. Perfect. So what was wrong is there is an ID column in both of those tables, so our select clause was ambiguous, right? Because we're saying select ID. I didn't know if it meant the roast ID or the user ID, right? So now I've got both of these tables are joined in this query, right? So I can say users dot column name. So I can say users dot what's the thing? Username, users dot email, right? And if I get this now, right, you can see that the information that was linked with this user ID column was brought in to the results of our query. Okay. Okay. Let's play with the minutes now, right? So let's call this maybe roast minutes. It's going to have an ID as well. Then it needs to have, let's see. It needs to have a roast ID so that we can associate it to the roast table. Roast ID int, not null. Okay, we don't want to make that auto increment. What else does it have? It has minute. Well, yeah, minute, int. Let's make this unsigned. It can't be negative minutes, right? Unsigned int, not null, default 1.
And then it would have, it has the temperature again.
Okay. And then it has temp. And what did we make that? That was just an int, right?
Yes. Yeah.
What else? Notes.
Yes, you have the notes.
And we probably would want to make that a text field so that there's enough room for us to type some stuff. Okay. Is that it?
No, and then there's like a, I have like a drop down of like, there's 4 different phases of like roasting coffee.
Okay. What are
there
those?
is, let me just get them really quick.
It was just like a single word or a couple of words?
Yeah, there was.
Yeah, so we could probably just do varchar 20. Okay. So this looks right? We got a
Yes.
roast ID, a minute, a temp, a phase, notes. Cool. So I'm going to create this table, which should have done it. Yep, roast minutes now. And if we put some information in here, Select. Good. All right, so roast ID is 1, minute 1, temp. What do we say? Maybe it starts at 100 and it's phase. What is it, like phase heating?
It's say like developing or something. Yeah, that's fine.
Okay. Started the roast. Okay. Then roast ID 1, minute 2. Now it's up to like 170. Heating. No note there. Roast ID 1, minute 3. 205, 270. Maybe this is a fast heater heating. Okay, and then minute 4 is 300. And then now we're in the cooking mode. Developed. We're developing. Right? Smells good. Okay. Then we do roast ID minute 5. 300. Maybe it's a little finicky, so it goes to 302. Developing. Okay, and so on and so forth. So I'm gonna just, right, so it's just inserting those records. But now what we have is, right, all of these are the notes that are coming back, right, for the for an individual roast. So we can do that same sort of relationship. Select star from let's do select roast.id roast. What do we have in here? Roast.target temp. Roast date. Is that what we called it? Yep. And then we can do roast minutes dot minute. Roast minutes dot temp. Roast minutes dot phase. From roasts left join roast minutes on roast minutes dot roast ID equals roast dot ID, right? What do we do here? Beautify. What we got? An error in our code here, so roast minutes. Why does it not show the errors? A little console window here. Put table test roast size. Oh, it's just roast. There we go. Cool. So now you can see, because we've joined this together, right, like we still get all of our roast information. Right, all the columns we asked back. ID, this is the roast ID, this is the target temp we're going for. So you can kind of see that if we put, target temp versus, we put these together, we execute, right, like you can look at the temp as it's going up through this roast log. Any questions about how we make relationships to data to different tables, right? So this is us joining one column on joining two tables together on one column. We can also join multiple tables, right? So if we still wanted username, right? If we wanted users.username, users.email from here, right? We can also left join rows users on roast dot user ID equals users dot ID, right? So we can join and get the user information that submitted that this roast belongs to in this same one query. We've now brought information from 3 separate tables into one table to give us everything we need to know. One query to get 3 separate pieces of information.
But for my table, since it's so simple, can I just create one table or one query?
No, and the reason you can't, you can create one query if that's what you mean, like this.
No, I meant 2 different tables.
So that would be like a discussion around database normalization. So way back in the old days, we would build one big table called roasts, and then we would make columns for minute 1, column for minute 2, column for minute 3, and so we'd have this table with 600 columns in it. Well, the problem is you're trying to build a dynamic application. So your user can roast something for 5 minutes, or they can roast something for 15 minutes. Or maybe they want to break it down in increments of 30 seconds, right? Like, we need to have our data model have the flexibility to have any number of minutes, whether it's 1 minute long and you're putting it into a preheated 350-degree thing already, and it roasts for just a minute or two, versus I'm going to put it in cold and let it warm up and roast slowly as the temperature increases. But like by having roast is the overall, like the page is the roast, right? When you're building your interface, I'm building a single roast that can have any number of minutes. This type of model gives you the flexibility to build a better and more dynamic website, rather than putting everything into one table where you're limited to the number of columns that you've added. There are some scenarios where it's appropriate, but in general, most of the time, and just to even like bring this point home, I'll show you. So let's look at Docket, for example, right? Like clients is the main table. I have a table with clients, and the information here is extremely lightweight, right? If we select rows here, right? I'm just looking at the URL, the name of the client, when they were created, when they were updated. Like this is the top level record. Well, then clients can have statuses and priorities and features, and they're all related based on the ID of that client. So I'm storing a bunch of stuff separately because there could be multiple priorities, there could be multiple statuses, there could be multiple features. The clients can have clients themselves, clients. They have categories. Then a client has a whole bunch of matters, which is a separate table, but it's still associated to that client, right? And if I select here, right, you'll notice that I have a client ID column, so that I can link in what client does this record belong to, right? This is a very common look and feel for what you're going to see in a realistic, real-world data model for an application, right? There's going to be all kinds of complicated relationships between your roast and your roast log and your users is going to have a password, and you might want to like have a notes field or comments, right? So even a roast can have maybe a whole bunch of comments. If you're building a tool for everyone on the planet to use, they can come in and say, I followed your recipe and it didn't work. And then you might have a reply to that comment, right? Like we're building things where we want to add more features and more functionality into. Databases give us that flexibility by letting us break our data into separate models. All right, so if you think of tables as like the design of how we're storing our data, it's like a big library where like you got index cards. And you have, for those of you who are kind of old and remember going back to the library, like each section of these index card slots, maybe like section A through Z is like a wildlife, and so it lets you know that if you read from this index card, you can go to the library in row 4 and browse through those books, right? We're storing a relationship to what the data will look like in a real world scenario, and so it lets us design better programs and make it a way easier to write code against.
So when I come back for like another roast in like a week or something like that, and I'm using this, this just updates from right there, correct? Like the next row.
Yeah. So you'd go and create a new roast, right? And it would be like, let me see if I can how to do this here in this stupid program. So, right. So your next roast would create a new record in here, and you maybe say, I want the target temperature to be 340 this time. Roast date will be that date. Batch size, maybe I loved the previous roast, and I want to see how it does when I do 8 ounces. And maybe a Colombian mix, right? So it's a slightly different bean mixture. Go ahead, Selena.
Would creating a users page also help so that you can associate the user with the user ID and all that good stuff? Does that make sense?
Yeah. And generally, when we're talking about application development, like the data is never going to be entered manually by a user coming in here and adding information into our database. We're going to build a page to let us build all these things. Like your roast page, for example, when you're in there as a form, right, you're building all that, the user's typing in all the roast information all the times, and you got pretty charts and graphs. When they click submit, it's sending that whole package of information to the server, and the server's going to grab that request and store the roast information in the roast table and store the minute information in the roast minutes table. So the first query you're going to make is inserting that roast record so you can get the roast ID back, because you need that for the rest of your pages. And the system will already know what user you are because you've logged in and authenticated to a user account in the users table. So all of this structure lets us build products that can actually do things. What else? All right. Here's what I want us to do for the next 40 minutes or so. I want everyone to go into your database. I want you to create a database schema. Create a database. So don't call it test. Call it something real. Give it a name of a product. Something you've been working on or something you've been coding over the last couple of weeks, as like an example. Maybe for Josh it's the roast app, or maybe you make a smoking app, or whatever. Something you guys have been working on. I want you to create the database and create at least 2 tables of your data model, right? So you'll probably need a users table of some kind. Think of, I need a user ID, I need an email address, I need a password, I need full name, first name, last name, however you want to split it up. I want you to create at least 2 tables, but however many tables you think you need to build those over the next, we'll come back at 7:30 and just do kind of a show and tell of what table structure you've created. Okay, does everyone understand the instructions? Cool. 7:30, I want to see your beautiful databases.